Welcome back. This is the third video on section 1.5, which is all about quadratic equations. And in this video, we'll look at the quadratic formula. So a quadratic equation is something that looks like this, where we'll have an x squared term, an x term, and a constant term. So ax squared plus bx plus c, and all that will be equal to 0. The automatic way of finding solutions to this is to use this formula. We'll have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now the plus or minus means that there will be two solutions, one with a plus sign and one with a minus sign. So one solution will be negative b plus the square root over 2a, and the other one will be negative b minus the square root over 2a. So let's apply this and see if we can use this to come up with some solutions. So here we have our quadratic equation. We've got an x squared term, an x term, and a constant term. So we can identify the coefficients. We have 2 times x squared. We'll have a 9 times x, and our constant term is 10. So plugging this into our equation, we know that our solutions are going to be negative 9 plus or minus the square root of 9 squared minus 4 times a, which is 2, times c, which is 10. Making sure that our square root sign covers everything. And we're going to divide this by 2 times a, which happens to be 2. So if we start simplifying, we've got negative 9 plus or minus, okay, we've got the square root of 9 squared, which is 81, minus 4 times 2 is 8, times 10 is 80. And all this will be divided by, 4. 2 times 2 is 4. So we can simplify this. We've got a negative 9 plus or minus, okay, here we have 81 minus 80 is just 1, and the square root of 1 is 1. So we have negative 9 plus or minus 1 over 4. So let's write down both of our solutions. We have x, one solution we will add, so negative 9 plus 1 over 4, or the second solution will be negative 9 minus 1 divided by 4. So for the first one, negative 9 plus 1 is negative 8, and if we divide that by 4, we get negative 2. Or in the second one, we have negative 9 minus 1, which happens to be negative 10, divided by 4, which we can simplify on the fly to be negative 5 divided by 2. Cancel a 2 off the top and the bottom. So we have two solutions, x is equal to negative 2, and x is equal to negative 5 halves. So one thing that we could do is we could check to make sure that this is a solution. Let's check the first one. If I plug in a negative 2 into the equation, all of this should be equal to 0. And if I take 2 times negative 2 squared is going to be positive 4, times 2 is 8. 9 times negative 2, well, that's negative 18, plus 10. And 18 and 10 is, 8 and 10 is 18, minus 18. That all adds up to 0, so check. We would also want to check the other solution. Let's look at this guy. So here, again, our coefficient of our x squared term is 2. The coefficient of our x term is also 2. And now the coefficient of our third term is going to be negative 1. So let's apply our formula. X will be equal to negative 2 plus or minus the square root of 2 squared minus 4 times a times c all over 2 times a. So again, simplifying, negative 2 sticks around, plus or minus the square root of 4, 2 squared, minus 4 times 2 times negative 1. 4 times 2 is 8, times negative 1 is negative 8. So if I'm going to subtract negative 8, it's the same thing as adding 8. The negative signs will cancel out, and all this will be divided by 4. So again, if we simplify, this will be negative 2 plus or minus. Off to the side, I'm going to do a little bit of scratch work. The square root of 12 is the same thing as the square root of 4 times the square root of 3. And the square root of 4, well, that's just 2. So this will be 2 square root of 3 divided by 4. And what I'll do on the top is I'll factor out a 2. So I'll pull a 2 out of the first term, which will be negative 1, plus or minus. And if I pull a 2 out of the second one, I'll be left with a square root of 3. Dividing everything by 4, I can cancel a 2 and be left with a 2 on the bottom. So the two solutions are negative 1 plus the square root of 3 divided by 2, and negative 1 minus the square root of 3 divided by 2. So those are my two solutions. They're not quite as nice as the last ones because we do have the square root of a non-perfect square. The square root of 3 can't be simplified anymore. So here, something different will happen in this time. Again, the coefficient of the x squared term is 1. The coefficient of the x term is negative 2. And the coefficient of the constant here is just going to be 2. So when I apply my formula, I'll have negative b, which is going to be negative 2 by itself. So we'll see that those negative signs will cancel out. The square root of b squared, so this is negative 2 squared, minus 4 times a times c, all over 2 times a, which happens to be 1. So negative negative 2 is 2, plus or minus the square root of negative 2 squared is 4, the negative signs cancel out, minus 4 times 1 times 2, well that's 8, all divided by 2. So again here, I'm going to simplify this off to the side. 4 minus 8 is in fact negative 4. And I have a square root of a negative number, so I immediately pull out an I. And I times the square root of 4 is 2i. So again, the square root of 4 is just 2 here. So when I simplify this, this is going to be 2 plus or minus 2i divided by 2. And again, I can pull a 2 out of the top. 1 plus or minus I. Pull a 2 out of the first term, I get 1. Pull a 2 out of the second term, I get an I. All divided by 2. Cancel, cancel. 1 plus or minus I. So my two solutions are 1 plus I, and the other solution is going to be 1 minus I. So we have two solutions here. Notice that neither are real numbers because they involve the imaginary number I. So here there are no real solutions. There are no real numbers that are solutions to this guy. The last one here, it should be 4x squared plus 4x plus 1. A is 4, B is also 4, and C is 1. So let's apply our formula. X will be equal to negative 4 plus or minus the square root of b squared, so this is 4 squared, minus 4 times a, which is also 4, times c, which is 1, all divided by 2 times 4. So on top, we've got negative 4 plus or minus, well, 4 squared is 16, minus 4 times 4, well, that's also 16, all divided by 8. And what you'll notice is that 16 minus 16, well, that's just 0. And the square root of 0 is just 0. So 4 plus or minus 0 divided by 8. So now this looks a little bit odd, because if I take negative 4 and I add 0, I just get negative 4. And if I take negative 4 minus 0, I also get negative 4. Adding and subtracting 0 doesn't change anything. So I might as well just write this. And I can simplify this. Negative 4 over 8 is just negative 1/2. So here, I only have one solution. The reason being, I took the square root of 0, and adding 0 and subtracting 0 doesn't change anything. One thing I'll point out is that I could see this originally from the following fact. I can factor 4x squared plus 1. This is going to be 2x plus 1 quantity squared. And I can derive this as a solution by noticing that this is actually squared. So I didn't have to use my formula here, but I did anyway. So one thing that's important to notice is this term appears under the square root sign in our formula. Remember, our formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. This is what appears underneath the square root sign, and it's called the discriminant. When b squared minus 4ac is greater than 0, I'm going to take negative b plus some number. If I take the square root of b squared minus 4ac, I'll have something plus something, and I'll have negative b minus something. So I'll end up having two solutions. So if you were to graph a squared plus bx plus c, you would see that the line for this graph has two solutions, has two roots, meaning this is where it hits the x-axis, meaning it has two x-intercepts. If b squared minus 4ac is equal to 0, in this equation, I get the square root of 0. So I'll have negative b plus 0 and negative b minus 0. Well, that only gives one solution. And the one solution is where this line will hit the x-axis in exactly one spot. And the last situation, which we saw a couple of examples ago, we had negative b minus 4ac is negative. Sorry, b squared minus 4ac is negative, which means that if I take the square root of that number, this is imaginary. Oops. So there are no solutions. The x-axis is never hit. So there are three types of solutions to a quadratic equation. You can either have two different solutions, two different real solutions, only one solution, or two imaginary solutions. And we've talked a lot about quadratic equations here. One thing to keep in mind is that the quadratic formula always works. It's just sometimes a little bit long to try to take these square roots and solve these things. So what method should we use in general? Well, if ax squared plus bx plus c is factorable, and you notice, oh hey, I can factor that right away, then factor it and it'll be easy. If you're in the situation where you have ax squared plus bx is equal to 0, well, you can pull an x out of this and you can factor right away. So again, you can just factor. When things are factorable, most of the time it's easy to just factor. In this situation, if you have ax squared just plus c, as in there's no x term, I can turn this into ax squared minus is equal to minus c by subtracting c from both sides. And now I can solve for x squared and take a square root. So again, if I divide both sides by a, I'll have x squared is equal to negative c over a, and I can take square roots to solve for this. So in this situation, again, it's fairly straightforward. We can just take square roots to solve. Now, more generally, it could be that I have some expression squared. So for example, I could have x plus 2 squared is equal to 3. So here u is just going to be any polynomial, and if I have that squared is equal to 3, well, I can start taking square roots and solving that pretty easily. And the one method that will always work, that you should always keep in the back of your mind, is just the quadratic formula. If this isn't factorable and none of the other methods really apply, you can just always use the quadratic formula. You'll have to be careful when taking those square roots.